Namaskar. My name is Somak Raychaudhury. I am the director of Inter-University Center for Astronomy and Astrophysics here in Pune. As you know, we are in Pune also in a lockdown, and I really am happy to be part of this series during lockdown to take your minds off all the discussion that is going on about the epidemic away, and we discuss some other things. And I'm happy today to talk about the tradition of Indian astronomy. Here at the Inter-University Center, IUCAA, we work in all kinds of astronomy to do with theoretical astronomy and observational astronomy using telescopes from all over the world, as well as in space. And we make these instruments, we make telescopes, we work with the rest of the world, we work with various organizations within India, including ISRO and the various departments of the government. And this work that we do now, along with all the universities and colleges all across India, many of whom also do fundamental research in astronomy. We bring them together and we help them work with each other and connect them to the rest of the world. And the reason we do this is that we have this unbroken tradition of astronomy, which is one of the oldest languages of science in India. It is one of the oldest traditions that we have had of rational thinking, and it is great fun to bring together people from many branches of science to look at the universe and understand how the universe works. The science in general teaches you to question, to understand, to peacefully discuss and debate, and then find out how one can understand natural phenomena. In astronomy, it is very special. And this is why I think Indians, from the very beginning of the acquisition of knowledge, have been very interested in astronomy. It is a very unique thing because it's the ultimate challenge. We in astronomy cannot go and touch and feel or manipulate our subjects like a biologist can, for example, or many other people can do in the laboratory. The things we work with are very far away. We can't go there. So we have to act like a detective. And we only can work with the light that we receive. And then, the various kinds of radiation that we now receive. But traditionally, for thousands of years, we could only look up at the sky and use our eyes and look at what is there in the sky and try to understand and make sense of what is going on. And in order to do that, we have to bring together almost everything that we know in science, in mathematics, and now physics, chemistry, etc., or everything that we do. And so all branches of rational thinking are necessary to make sense of all this. And this is why astronomy has always been considered to be one of the toughest subjects, and Indians like tough challenges. And so it was always been taught to scholars, right from the days of Nalanda and Takshashila, Gurukuls of ancient India. It has always been part of our curriculum. Now, traditionally, when we are, as humans, learning to look at nature and understand what's going on, astronomy has been quite important because even the earliest humans understood that the sun is the source of our life, our warmth, and the rains affect our life, the sky in various ways affects our life. And so the sky then becomes, and of course, this was long before we had other sources of entertainment, television, Netflix, whatever. And so after the darkness descended, the sky was the canvas for our entertainment. And so we looked at what's happening in the sky. There was no human who was not fascinated by the sky. And so the sky became the abode of the gods. And our myths, our stories, our imagination, a lot of it was concentrated on describing what's happening in the skies. But it's also, we needed astronomy for many things. It's not just to worship the gods who lived in the sky or to understand what's out there, but we needed astronomy, very important things. We needed astronomy for navigation. So not just navigation on the seas, but if we wanted to go from a village to another village, even to walk there or go on some kind of a vehicle, we navigated by the stars. We knew exactly which direction things were by looking up at the sky and looking at, and so there was knowledge within us in the tradition that we had of navigation. Then, being an agricultural society, eventually we needed to know what time to sow our seeds, when to harvest, when the rains will come, when it will get warm, when it will get cold, and all that we could see through the stars in the sky. The stars would tell us where the sun is, it would tell us, and that is why, as you can see, our months are named after the nakshatras, which are in the sky and at that time, and when the sun, with respect to the sun. We also needed to know about the dates of the different festivals. The festivals are dependent on the solar calendar, the lunar calendar, and where the sun is with respect to the different constellations in the sky. And so, in order to figure out when the festivals are coming, when our various occasions will happen, we started looking at the sky and naming the different parts of the sky after various shapes that we saw them. And this is what we call constellations. These were ways for us to remember where to look in the sky. And in looking at where the sun is during the day and at night, what part of the sky the constellations are, we could figure out the time of the year as we know it now. Also, as you know, our festivals are related to events in the sky. And for example, we know that the vernal equinox happens at a certain time. That is the time also we know that spring arrives. So the vernal equinox is a very important day. We now know it to be the 21st of March or 20th of March. But today, for example, is Good Friday in the Christian tradition, and Easter is on Sunday. So, for example, in the European tradition, Easter comes after, it is the first Sunday after the first full moon, after the vernal equinox, right? And so even in that tradition, in the whole of the world, people would know when the vernal equinox would be, and then they would know when Easter will come. Similarly, our Diwali is the first Amavasya, the first new moon, after the first full moon, the Purnima, after the autumn equinox, right? And so things like that. So our festivals and festivals worldwide would be decided upon the equinoxes and the solstices. So we had to know when these equinoxes and solstices will occur and what that means. Then we would be also very wary of various things that happen in the sky. For example, comets will arrive. And in many traditions, comets meant things. They meant that something will happen after that. And people who believe in astrology would believe that they are related to the arrival of transient things in the sky, comets, or maybe a star explodes into a nova or a supernova. And then there will be eclipses. So solar eclipses and lunar eclipses also mean things in our tradition, and often they are connected with religious beliefs. It's often connected with beliefs that they would lead to certain things that we should be afraid of, things like that. So a lot of these traditions that we have are linked to celestial phenomena, and knowing when these things occur and what they mean have always fascinated us and have been a very important part of our tradition. Now, if you look at how science has evolved, in particular mathematics, which has been there for a long time all over the world, the mathematical tradition was particularly strong in the Indian tradition from the very beginning. And later on, what we now call physics and chemistry, which in various forms grew in India and in the West, often talking to each other, often independently. All these things have been motivated by some of the questions that have come from the sky. I mean, Newton invented his notion of physics, from which the Western tradition comes, trying to understand why Halley's comet comes back, for example. Similarly, our own tradition of mathematics, of arithmetic, of algebra, of geometry comes from this tradition of understanding astronomy. And this is why the tradition of astronomy is very, very important. Now, astronomy is also connected with a lot of what we are in terms of the stories we hear from when we grow up. So, for example, the myths and the legends and the stories of our religious figures, the stories from the Ramayana, the Mahabharata, and the various other kinds of epics that we grew up with, you will find that astronomy is very, very intricately interwoven with them. And this is because in the sky, there is drama. If you, I mean, there is the drama of thunderstorms, drama of eclipses, drama of rainbows, and drama of rain, and all that. And that enters into our stories, and we make them into stories, and these stories become part of our lives. It is in the oral tradition. And this oral tradition also then embeds into them concepts so that we understand astronomy. Right. So, for example, here I'll give an example. So I told you that we create these nice shapes in the sky, which are called constellations, and give them names. And these names, if you look around the world, you will find that these names of the various shapes that we see in the sky, the constellations, are connected with wonderful stories. And these stories mean things, they have functions. I told you that we need astronomy for navigation. And so if we know that in the sky there are some constellations that are in a certain series, and that can give us a path that we can take to go from one place to another. It could be on a ship, on a boat, or even on land. And so you can build stories around them, and you create these stories in order to remember these, and then they get related to prominent figures in our mythology, and so these then become part of the stories that help us understand where these things are in the sky. Let's take the example of Pleiades, for example. Pleiades is as you know, in India we call it Kritika. And Pleiades, they are a group of 6 or 7, or some people see 8 stars in them, and they are in the sky, not far from when you look up in the sky and see Kalpurush in the sky, Orion, and then you see Taurus, the bull, and across you see Kritika. Now, in our tradition, and then the other part of the sky, you see what we call the Saptarishi, which is 7 stars in the form of what looks like a question mark. We call it the Saptarishi. In the Western tradition, they call it the Great Dipper. And in the Great Dipper means it's like a saucepan. It's like you dip something, right? So in various traditions, there are various things. Now the Saptarishi have a particular position with respect to the Kritika. Now in our tradition, we know that the Saptarishi are the famous rishis of the Vedic period, and these Saptarishis, each star is named after one of these rishis. Now, we also know that the 6th star is Arundhati, which is the sixth star has two stars. The sixth star has two stars, and the companion star is called Arundhati, who is the wife of Vashishta, and so which is the sixth star. Not any of the other stars have a companion, and so we have built a wonderful story around it, which talks about Agni, who the god of fire, who was actually in love with apparently this is the story, with the wives of the seven rishis, who are the Kritika, the seven wives of the seven rishis, and then Agni met a nymph who seduced him, taking the shape of each of these women who are the wives of the Maharishis. And then, but Arundhati was such a pure woman that this particular nymph could not take the shape of Arundhati. And when and Agni was seduced by the shape of these famous women. And then when the rishis learned about this happening, they banished their wives all across the sky. So the Kritika forms by the six rishis' wives sitting together in one cluster called the Pleiades, the Kritika, whereas Arundhati gets to stay with her husband. So this is just a story. It is made up of this particular configuration in the sky, but it is a story to remember that where the Kritika is, where the Saptarishi is, and in the middle there's the Kalpurush and etc. So it could be that this kind of a story could have been created as a result of us wanting to know how to look at the sky and how to make a route to go from one place to another, and that becomes part of our tradition. So these are wonderful ideas that people have. And of course, now Pleiades in various traditions have various other things. For example, if you look at the tribals in central India, the Gonds, they have a story of the Kritika being actually a bunch of seeds that are thrown at birds. And then in the Greek tradition, they're called the Seven Sisters and things like that. So each tradition has their own wonderful stories that are built across the sky. And there are lovely connections between the mythology as well as what is in the sky. Now, the interesting thing in India is that we have an unbroken tradition of the Sanatana-Dharma, which has been there for many thousands of years. And this tradition links these stories, the myths, together with the rishis, the gods, and the various other characters that are there in the tradition with the sky. And there is this unbroken tradition we have, which has built together for generations and have passed them on to us. And we can actually trace these nice threads back very, very long ago to see how the sky was described. And we can also look at the changes in the sky through these stories, because the sky changes quite a bit because the Earth's orbit changes. So these are very interesting things. Now, of course, constellations are not the only things that are studied in looking at the sky. We look at how planets move, how the moon moves, and how everything else moves. There are many reasons for that. One of the reasons is, of course, astrology, which I'm going to talk about today, because I'm not an astrologer. But in those days, in the days that I am talking about, 1,000, 2,000, 3,000 years ago, astronomy and astrology were not very different. People who are astronomers were also astrologers. They actually did astronomy mostly motivated by astrology, because they also wanted to understand, they wanted to predict where a certain graha or nakshatra will be at a particular point. And a lot of the mathematics that we have now came from trying to understand this, trying to predict the positions of the planets, as we'll see in a minute. So the other things that we have from our old tradition, thousands of years ago, are structures that we built, which are called megaliths, for example, for the megalithic period, which are huge structures. We know of famous structures from Europe. For example, we know of Stonehenge, which is a megalithic structure. which were built many thousands of years ago by people who wanted to study celestial phenomena and alignments in the sky and alignments on the earth with things in the sky to predict, for example, exactly the direction when the sun will rise on a particular date, to know when exactly vernal equinox will happen, because then, of course, as I told you, our festivals, the dates of the festivals would be predicted, etc., etc. So, but a lot of people don't know that in India, there is a huge tradition of megaliths that have been built. I mean, we find thousands, many thousands. I mean, the last time I looked, there were maybe 2,500 or 3,000 megalithic structures that are known mostly in southern India, which are not very well studied. And this is something that we need to take up and look at our tradition of building these megalithic structures. Many of them are connected with temples. The temples, when the temples were built, they were built with certain directions in mind, to know when on certain days the sun, where it rises. You know, as you know, the sun rises generally in the east, but not in the same place every day. The place where the sun rises and the place where the sun sets on the horizon changes every day, and so to know when where the sun rises on the horizon in a particular direction gives us some sense of the day and the season, etc. And so to actually make accurate measurements of such things, these structures, the megalithic structures, which are large stone structures that were built all over the world, and India has a long tradition of such things. And they're often connected with temples, often connected with just villages, central structures in villages, and where people would use them to know from their shadows or from the direction of the sunrise or the sunset with respect to the structures, something about when in the year they are. We also need to know, for example, and predict the phases of the moon. And as I said, they are connected very much with our structure of festivals, when we will have our festivals, because then, as I said, we need to know the equinoxes and the solstices, but we also need to know when Purnima is, when Amavasya is, when Shashti comes, when the Panchami comes, things like that. And we need to understand why that happens. And traditionally, we've known of why the moon has phases for many thousands of years, and so we can predict how that happens. And then comes the eclipses, and we'll all be able to understand where the sun goes. Now, there is a very interesting thing that we had in our tradition, and that is we noticed from very early on, I think worldwide humans noticed this, that the sun and the planets are the only things that move in the sky. Of course, the stars don't move much during our lifetime. Of course, it moves during the night because the earth moves. But if we go back to the same part of the sky, we see that with respect to each other, the stars don't move. They move over thousands of years, but not during human lifetimes. But we see that things that move very fast, and they're in different places of the sky, are what we then call planets. And so they became very part of our whole mythology and astrology and everything. And these planets, we noticed, actually go across the sky along the same path as the sun goes, and also the moon goes, right? And this is because now, of course, we know, in our modern knowledge, we know that all these planets are going around the sun, and they're all in a plane. And so we are also in a plane. The Earth is in that same plane. And so we can see all the planets, and this is Mercury, Venus, Mars, Jupiter, Saturn, all of them, they are all in the same plane, as is the sun and the moon. And so we see they are moving in the same line, and this line must be very special. So this is the line that we call the ecliptic. And so in the Indian tradition, we called this line of the ecliptic the most special place in the sky, and we divided that up into 12 zones for the 12 months. and we gave them the names of the rashis that we use in astrology. And so there we have, and so the sun spends for each month in one of these rashis, and it goes across the sky, and then and we study only that band in the sky. Now, in the European tradition, the same thing happens. They call this the zodiac, and they actually study only that part of the sky. And this is because the Indians and the Greeks interacted quite a bit about 2,000, 2,500 years ago. And our tradition of astronomy and astrology and their tradition of astronomy and astrology are very similar. This is very different from many other kinds of astronomy. For example, in China, the belief was that the entire sky is important, not just this bit. In fact, they believed that if you have any natural phenomenon, or for example, the king will change and a new king will come, or an earthquake will happen or something like that, it will be seen in the sky. And so all the kings used to employ astronomers. Astronomers were very coveted. There's a job of astronomers is very common, which is not the same thing now. But astronomers were employed by all kings, and these astronomers would look at the entire sky and jot down what is happening in that part of the sky. This is why there are so many amazingly detailed records of the entire sky. And whenever we look at, we want to know what happened many, many thousands of years ago in some part of the sky, we go into the Chinese records, and often they're there. In India, we actually have documented one part of the sky much more carefully than the other parts. And of course, that documentation is there. So the tradition of Indian astronomy is to understand the zodiac very well, and the way the sun goes, and the nakshatras that are around the main stars and the main asterisms that are around the path along which the sun and the planets move are called the nakshatras, and these are the most important part of our astronomical tradition. One of the things to know is that, of course, when we talk about the Indian tradition of astronomy, and we look at many thousands of years, we have to know that the Earth itself is precessing. It precesses like a top. So it's not just going around the sun and rotating on its axis, but it's actually going around like that in every 26,000 years, like a top goes. And so the way we look at the sky, the relative positions of these things change quite a lot. So for example, right now, we have Polaris, the pole star, which is exactly pointing towards the North Pole of the Earth. But many thousands of years ago, say even 5,000 years ago, that was not there. In fact, Abhijit Viga was there as our pole star. And 5,000 years ago, now it is Polaris. So these things change. And as a result, for example, vernal equinox, which is the 21st of March, is called the first point of Aries, both in our Indian tradition as well as in the Greek tradition. And that is because the sun would be in Aries. But actually, if you look at the sky now, it is not in Aries, it is in it is in Aquarius. And 10,000 years ago, it was somewhere else in Leo. And so the reason we call the vernal equinox to be the first point of Aries is that that helps us date when this whole system was started, and that is roughly about 2,500 years ago. It's time of the ancient Greeks. That is when we interacted very closely with the ancient Greeks, the Indian tradition, and that is why we have this system which is similar to theirs. And from that we have a lot of the tradition of dividing up the sky and finding out where the sun is. We started working on it now. Of course, now we know how the Earth precesses, and we can make these corrections. And in many of the ancient Indian texts, which I'll talk about very briefly very soon, actually tell us how to make these corrections. And our people who have, without much knowledge of astronomy, of the mathematics of astronomy, which is actually very, very complicated because of the various rotations that are going on, can actually make these calculations using a lot of tables that there are published in our texts of mathematics that get into making of the modern panchangs that we use in order to figure out where these grahas and nakshatras are. Now, in order to understand the connection between mathematics and astronomy, I think it's very, very important because Indians have always been extremely good at mathematics. A lot of mathematics we hear all over the world that is used now originates from India in the various stages, and I'll talk about a couple of them in a minute. And you might ask, why are we so strong in astronomy, in mathematics? And that is because of astronomy, because the tradition of Indian astronomy wanted us to understand the mathematical nature of the way the planets move in the sky. Now, with the current knowledge, the 20th century knowledge of physics, where we understand gravitation, we understand how the various forces work from Newton and Einstein, etc., we can actually calculate a lot of these things in a very different way. But what the ancient Indians were doing at that time were looking at the sky and very accurately measuring the positions of the various planets and trying to understand how they move. And in order to do that, if you know, I mean, it is very simple. If you know that the Earth goes around the sun and there's a centrifugal force, and you can calculate, there's a single equation, and you can calculate all of that stuff. And then, of course, it rotates, and then it precesses, and all that kind of stuff. But if you actually want to make sense of how the planet moves in the sky and try to figure out how to predict where it will be on a certain day, then you would require a very, very complicated set of mathematical formulae. And this is what we developed to do that. And in order to do that, as you can see, these are not linear motions. These are the planets move at varying speeds across the sky. And in order to understand that, we'll have to understand a lot of how the geometry works, the algebra works, and how spherical trigonometry works. And these are the things that were developed in our tradition to do all this. And so it's interesting because I'm very greatly interested in Varahamihira. Varahamihira was, of course, a very famous astrologer and an astronomer in the 6th century. Of course, he was at the court of Vikramaditya as a part of the Navaratna. He was actually the librarian. In fact, that is why in my institute in IUCAA in Pune, the library is named Varahamihira. Varahamihira wrote a book called Brihat Samhita. The Brihat Samhita actually is a compendium. It's an encyclopedia of, because he was a librarian, he collected together a lot of the knowledge of mathematics and astronomy at that time. And it is hard to know how much of that is original, his own work, and how much it is like an encyclopedia, a correct collection of things. And in that, he actually defines an astronomer. He tells us that astronomer is a very, very important person. And in that tradition, I'm talking of the 6th century, right? This is 1500 years ago. And he's talking about, to be an astronomer, you have to understand the nature of time. You have to understand the division of time into yugas, into seasons, into kalpas, into various different kinds of the divisions we have. And that is another feature of Indian astronomy, is that we actually recognize that time can be very large. And there's an expanse of time. And we talked about infinity and very large numbers. If you look at corresponding notions of time in the Christian tradition, a lot of people believed that the universe was only 5,000 or 4,000 years old. In fact, Newton wrote a whole book on cosmology, in which he tried to prove that the whole universe was only 4,000 years old. But in our tradition, there is the notion inbuilt that there is time is infinite, time is very, very large. And so we actually have dealt with very large numbers in our mathematics. And Varahamihira tells us that in order to be an astronomer, you have to understand the nature of infinity, the nature of very large numbers. He also defines an astronomer as somebody who understands the calendar. He understands solstices and equinoxes, can calculate the times of the eclipses. He also can understand how the sun moves around the sky and can tell you exactly where the sun will be on a particular date, where they will be. And he also tells us that we should also be able to understand where a certain nakshatra will be in with respect to the zodiac, right? He does not talk about astrology here because he knows the difference, even then, the difference between astrology and astronomy. He wants an astronomer to be a mathematician and as a mathematician to learn all this. So as we read this, and this is written in the first part of the 6th century, we understand that at that point, we did know how to do a lot of this, right? And this comes, as we see, in the tradition of Aryabhatta. Aryabhatta was a contemporary of Varahamihira. He lived between 476 and 550. So that is the 5th and 6th century, and he lived in Pataliputra. And Aryabhatta, if any of you have come to my institute here in Pune, you would see a wonderful statue of Aryabhatta because he is kind of the father of our kinds of mathematical astronomy. The kind of thing that Varahamihira is talking about, Aryabhatta is the example of that. And Aryabhatta, in fact, if you go to Wikipedia and type Aryabhatta, you will see the picture of this statue of which we have in IUCAA, because there isn't, of course, any other image of Aryabhatta. Aryabhatta did a lot of things. We hear about Aryabhatta being the inventor of the decimal system, Aryabhatta being somebody who worked out some of the basic things in arithmetic that we know. But one of the interesting things in astronomy is that Aryabhatta knew that Surya, the sun, has its own light. And all the other planets, and he talks about Shukra, talks about Mangala, talks about Buddha, talks about Shani, all of these planets have reflected light from the sun. They don't have their own light. He figured that out. He also figured out that the moon also shines by reflected light from the sun. And that is because he worked out from which direction the sun's light comes as he saw the moon in various places. Now, then he writes in his Aryabhatiya, which is the major book that he wrote, that where there is light, the reflection of light, there is shadow. And thus he realized that eclipses are essentially shadows. You have to understand that he's not taking this whole concept of Rahu and Ketu that we also see from our legends literally. He's not talking about eclipses happening because there's a monster that comes and gulps the moon or the sun. He understands that the eclipse is a shadow. And I'm talking of 500 AD. He also understood that the earth is spinning on its own axis. Now, this is very difficult to understand because we are standing on the earth. We are not feeling the earth moving at all. Aristotle had an argument in the original Greek tradition of why he thinks that the earth is moving. Aryabhatta has his own independent argument. He also, and this is very wonderful in astronomy, he accurately measured the size of the earth, very, very accurately, by looking at the sticks and their shadows at various locations. He went around various locations, he measured distances between them, and looked at a given time, the direction of the shadow of a stick that is in the ground. This is very similar to how the Greeks had measured it. Eratosthenes had measured the size of the Earth, but Aryabhatta did this independently, and he described this in his Aryabhatta. So, and he was also very, very interested in the nature of time and the length of time. So he fulfilled, I think, for example, probably Varamihira was thinking of Aryabhatta when he talked about the astronomer. He had a treatise called Kala Kriya. In this Kala Kriya, he describes in great detail how to calculate the eclipses, the eclipse of the sun, eclipse of the moon, and then he has a very, very mathematical book called Gola, talking about a sphere, Gola. And towards the end, he very absolutely in I'm not telling you the Sanskrit, but he writes in a wonderful description of how when the moon enters the shadow of the sun, on some days of Purnima, of the full moon, that the lunar eclipse happens. And he talks about how the solar eclipse happens when the Earth enters the shadow of the moon. So, and then he calculates, shows how, and we still use this formula. He shows mathematically how to calculate the size of the Earth's shadow, which is in a way Rahu. And he writes in verse. In the verse, he shows us how to calculate the duration of the eclipse, how much the eclipse will last, and he will tell you how much of the sun will be eclipsed. With it calculate whether the sun will be totally eclipsed or partially eclipsed. Everything you can work out. And this is being written at the beginning of the 6th century. That is absolutely amazing. So he had a very interesting following, and the generation after that were the Aryabhattiyas, the followers of Aryabhatta, and the most prominent person in that tradition was Bhaskara. So this is the first Bhaskara. There are two Bhaskaras in our tradition. I'll talk about both of them very briefly. And the first Bhaskara actually lived in Saurashtra, which is now in Gujarat. And so he wrote a big book called Mahabhaskarya. And in this Mahabhaskarya, he actually attributes almost everything to Aryabhatta. So this is why we think he was one of the disciples of Aryabhatta. And there are many such disciples. There are Haridatta, Govinda Swami. There are some very interesting mathematicians at that time who follow just in the early 7th century, 600 AD or so. But Bhaskara, I think he was a little humble because he gives some very interesting formulae which we can't find in Aryabhatta's work, but he attributes them to Aryabhatta. He said Aryabhatta said this, Aryabhatta said that, etc. And so he does wonderfully. For example, he gives a wonderful trigonometric formula of an approximation of sine x, which is accurate to 1%. And he says Aryabhatta says that. We can't find it in Aryabhatta's writing. But actually, it's described in Bhaskara's book. And then he was also a wonderful poet, and so he has another book called Aryabhattiya Bhashya. And in the Aryabhattiya Bhashya, he actually goes and in beautiful verses. There are 33 sets of verses in which he outlines the mathematics that he says comes from Aryabhatta, and this is how to solve quadratic equations, how to deal with cubic equations, how to deal with equations with more than one unknown, things we learn in algebra in school, in lovely verse. And then in the rest of the Bhashya, he talks about Aryabhatta's work on eclipses. And in those eclipses, he also brings in, as a poet, the natural beauty of these eclipses and what the world looks like when the eclipses happen. So here is a wonderful place where mathematics and astronomy, science, and poetry come together. And this is another wonderful part of our tradition of very nicely writing about very hard topics like mathematics and astronomy. But the more important Bhaskara comes much later. Bhaskara, as I said, Bhaskara I, the first Bhaskara, who was in the 7th century, was a disciple of Aryabhatta, and he himself, maybe due to humility, but maybe due to just, maybe it is true, he described most of the work that he wrote down as part of Aryabhatta's work. The most original person in the history of India's pre-telescope astronomy and mathematics was Bhaskaracharya, or the second Bhaskara, Bhaskara II, who comes in the 12th century, about 1120, 1130, that kind of time. He was born in Bijapur, but he lived in part of Maharashtra, which is now in Jalgaon. And this is where he lived and wrote some absolutely amazing mathematics. And most of it was motivated by astronomy. His most famous book is, of course, Lilavati, which is named after his daughter, who was also a mathematician. And Lilavati is a book of arithmetic. So it is Patiganit, and there's lovely descriptions through his shlokas of how to deal with series, of progressions, of permutations and combinations. And this is a book, Lilavati. And then he wrote another book called Bijaganita, which, as you know, is the word for algebra. And here he talks about the concept of zero, that comes from our tradition that goes all the way back to Aryabhatta. And he deals with how to deal with zero, how to deal with infinity, things that come into European mathematics much later, where people are grappling with, he's grappling with the concept of infinity. What happens when you take away infinity from infinity? What happens when you multiply infinity with other numbers and things like that? And this is in his Bijaganita. He's talking about positive numbers and negative numbers, and exactly the kinds of algebra that we do in school. He introduces all that. So a masterful book on arithmetic and algebra. Now, he has to do all this because his ultimate aim is to understand astronomy. And I'll come to that in a minute. But his main book is called Siddhanta Shiromani. Siddhanta Shiromani is a book on astronomy. And it is divided into two parts. The first one is called Graha Ganita. Graha Ganita, of course, you can understand what that means. It is the Ganita, the mathematics of planets. And it has about 500 verses in 12 chapters. And each verse tells you how to calculate the longitude of a planet, which means where it is on the orbit, and how to find that in terms of time. And in converse, when you find where a planet is with respect to the sun, whether you can use that to calculate time. And he relates time with direction, with space. He then uses these things to predict eclipses and to work out the rising and setting of various planets. So on a particular day, when will a planet rise? When will a planet set? On a particular day, will you be able to see a certain planet in the sky or not? All this he works out because he has worked out the algebraic equations of all of these. And in this, the Siddhanta Shiromani, the second book is called Goladhyaya. And that is what we now call spherical trigonometry. In fact, if you look at the subject called astronomy in most Indian universities, it's taught in mathematics, and what is taught is taught as spherical trigonometry, and this is essentially the earliest part of spherical trigonometry. It comes from Bhaskaracharya's book, Gol Adhyaya, and he works out the fundamentals of three-dimensional geometry. Some of it, of course, comes from Euclid, and he was aware of all that, but this is working them out in terms of algebra and in terms of various equations. He works out geometry on a sphere. He works out how things move in a sphere. He understands that the motions of the planets is actually a three-dimensional problem. It is not it is not just on the sky in a plane. And so he works out the motion on a sphere. He has works out eclipses in 3 dimensions, And then in a wonderful chapter called Ritu Varnam, he talks about how seasons, the various seasons occur, why they occur, and he actually goes into poetic mode of describing the seasons, which is absolutely beautiful. So Bhaskaracharya also had this lovely poetic angle to him. He also has a very, very important chapter, something I have not talked about today because I don't have really that much time. He had a chapter called Bhuvana Kosha, which talks about cosmography, cosmology. Wants to figure out how the universe is all put together and who goes around whom and things like that, and what is the history of the universe. And this whole story will be incomplete if I don't talk about Bhaskara's work on differential calculus, because this is 500 years before Newton and Leibniz. Bhaskara has worked out some of the basic results that we now use in calculus, which is essentially derivatives. He, for example, shows in one of these places how you can take a derivative differential of sine x and its cos x, and uses that in his calculations, right? He, of course, doesn't call it derivative. He doesn't call it ddx or whatever, as we would call in modern mathematics. That notation comes from Newton. Leibniz gave the notation of integrals. Those notations he, of course, doesn't use, but he has lovely shlokas that tell us how to go from how to find the derivative of sine x and things like that. So the basics of differential calculus was already there, and this lays the ground for the hero of this kind of mathematics, and that is Madhava. And I'm not going to talk much about him today because I don't have time. Madhava comes in the 14th century. He was born in 1340. He lived in Thrissur in Kerala, and the whole Kerala school of mathematics is something else. It's wonderful. And again, and Madhava actually invents a very early form of calculus based on some of Bhaskaracharya's results, but he actually lays the ground of what are the basic results of differential calculus and uses it to find the positions of celestial objects and looking at how these planets move in their orbits for the first time. Before this, in Aryabhatta's tradition, in Bhaskara's tradition, these were done by using difference equations. This was done by using algebra and solving sets of equations. But the best way of doing it is using calculus. And of course, that is how Newton did it later on. But Newton had the additional input, and that he had postulated various laws of physics that, of course, Madhava and Bhaskaracharya did not have. But purely mathematically, they tried to find a formalism in which they could then find how to more accurately predict the various motions of the objects. So I think in this entire presentation today, I've been able to focus on, I did not talk about Vedic astronomy, or mathematics before 2000 years. We had a whole tradition of mathematics and astronomy that came from the Vedic period, from the Harappan civilization. We find a lot of studies that have gone into understanding the sky. And but I talked about how the very sophisticated form of mathematics was developed to understand how the sky moves, how the planets and the stars move, and the Earth moves together with them in a very, very rigorous way. The astronomy of today comes from that very much. My colleagues and I work in a tradition that was laid down by these giants of mathematics, and that is why India has always been wonderful in theoretical mathematics and theoretical astronomy, theoretical physics. I did not talk about the tradition of building instruments to actually verify some of these things. Aryabhatta did this, and his followers did this. They built various kinds of instruments to find out how to measure things from the megalithic tradition, but also making gnomons and making sticks and shadows and stuff like that. Maharaja Jai Singh in his Jantar Mantars demonstrated how some of these things can be built on a much grander scale to make accurate measurements. In modern astronomy, we have telescopes where India's gone into an era where India is moving from this tradition of purely theoretical astronomy and astrophysics into building very large-scale telescopes to make measurements. It is from our tradition of doing rigorous astronomy. You all know that India is now involved in building telescopes that go into space, and ISRO is launching them. We have Astrosat in space. We have Aditya going up to study the sun. We are involved in the Gravitational Wave Observatory, LIGO. We're involved in the 30-meter telescope and all that. And I would say that the tradition of us that we have remains unbroken from the tradition we had of trying to understand the universe and the sky. I'll stop there. Namaskar. Thank you very much. I will just look through the various things that you have written in the live chat and see whether I can answer a few questions. Otherwise, thank you very much for listening to this, this series of lockdown talks, trying to keep you entertained during the lockdown period. And I hope you're keeping safe. Let me read out some of the questions, and I'll try and answer the ones I know. I have somebody here who has asked, Shiva Maurya has asked, sir, how are the megastructures like Jantar Mantar, how did they come into existence? Actually, the megastructures I talked about, the megaliths, come from many thousands of years ago, and they were built by people, we don't know who built them, but they were built to find out various directions from which the sun would, and the various other stars and planets would rise and set. Jantar Mantar comes from the constructions of Maharaja Jai Singh in the 17th century, and this is actually built in the modern era. I'm not talking. I haven't talked about that era. In fact, Maharaja Jai Singh possessed telescopes. He knew telescopes. This was after Galileo's invention of the telescope. But he was also building these mega structures to make quite a lot of very interesting measurements in the tradition of what Tycho Brahe had done in Europe. And some of these structures, and if you're very interested, you should attend lectures by Dr. Ratnashri, who is the curator and the director of the Nehru Planetarium in Delhi, who has given quite a lot of lectures and on how Jantar Mantar can be Jantar Mantars in various places in Delhi, in Jaipur, in Bhopal, in Banaras. They can be used to make measurements, and so these are relatively new in this tradition of Indian astronomy, but they are wonderful structures that can be used. There are, let's see if there's any other people who have asked questions. We have a question from Shomit Bhattacharya, who asks, sir, how can we become an astrophysicist in India now? Yeah, of course, Aryabhatta had a very strong, very, very hard life in becoming an astronomer. In the old days, we have a lot more happening in India now. To become an astrophysicist, you have to study physics and astronomy, physics and mathematics very, very well. To become an astrophysicist, you can come from many different directions. For example, you can study physics or mathematics in university, or you can study engineering in university, because astronomers have to build these telescopes. They have to build telescopes in space and on the ground, and those are the job of engineers. And so we require, in fact, if I look at the students in IUCAA, my institution, PhD students who are doing research in astrophysics, and my colleagues, many of them are engineers from various engineering colleges and IITs. And many of them did mathematics for their BSc and MSc, and many of them did physics for their BSc and MSc. And nowadays, even doing chemistry and biology, you can come into astronomy because there are wonderful subjects that called astronomy, astrochemistry, astrobiology. There's a new subject called astrostatistics, where a lot of data scientists can get into astronomy. We use machine learning, we use computer science, statistics in astronomy. So you can come from any of these. And what happens is that you have to do either a BTech or an MSc in any of these subjects and sit for some of these national exams, which will qualify you to do research in astrophysics. So that is the answer to what you asked. I am looking at any other questions that you might have asked. A lot of people are saying hello and hi there, and I can say hi there back. But I think somebody asked me, have you heard of Madhava? I hope I talked about Madhava, so you would know. So why don't the Western scholars accept that somebody asked, somebody called Raghav has asked, why don't the Western scholars accept what Madhava has done in his calculus? Of course they do. Who doesn't? I think there have been wonderful now books written on Madhava's work. My colleague, Professor Padmanabhan, has written a wonderful book recently. George Joseph's Crest of the Peacock talks about Madhav in a huge way. And there are some really good books now. Divakaran, Professor Divakaran of the Tata Institute has written a wonderful book on Indian mathematics, in which Madhava's work is very well written out. And it's just that what he did is not the same formulation of calculus as Newton and Leibniz's. And so we have to understand what the calculus that we learn in college now is the Newtonian way of doing it. But some of the basic ideas, the ones that we use in dynamics, was there in Madhava's work and earlier in Bhaskaracharya's work. And I'm sure people who are scholars of mathematics, now understand that this was done. A lot of people, a lot of my European colleagues do recognize that 500 years before Newton, we did have quite a lot of the basic mathematics already here. Please look at what the next talks are going to be in Lockdown Live. We have tomorrow Dr. Vasant Shinde talking about applications of DNA science. There's on Saturday, we have this every day. I'm also looking at, thank you for, many people have liked this talk. Thank you very much. Thanks. Are there attempts made to revival of this ancient science? I think, I don't know what you mean by revival. I think it is an unbroken tradition. I think a lot of what we do now comes from that tradition. So you can call that revival. I mean, think about, we use the kind of formulation that Aryabhatta and Bhaskara and Madhava and Bhaskaracharya have done in a lot of our work now. So that is being revived. There are quite a lot of things that can be done. As I told you, we have very seldom studied our monuments, the architectural monuments that we have, the archaeological sites we have, which show the connection with our traditional science. And this needs to be looked at. The megaliths and the temples, structures that relate to astronomy is a subject that quite a lot of people have been working on, but not enough. Mayank Vahya, my colleagues, Sri Kumar Menon, they've worked on lovely examples of some of these places, but a lot needs to be done. Also, there's another thing that I have to say in this context, and there's another question. There is somebody's talking about this as well, and that is, I mean, I said that when we want to find records of phenomena that have happened a long time ago, say a supernova, think about the Crab supernova. The Crab, on the 4th of July, 1054 AD, there was a star that exploded in the constellation of Taurus. And that has left behind what we call the Crab Nebula now, 1,000 years later. We don't see that explosion, but we see the remnant of the Crab Nebula. And that has been studied in many ways by astronomers using telescopes all over the world and in space. But when it happened on the 4th of July, 1054, it would have been seen all over the world. It was so bright that there would be almost a second sun in the sky for 2 weeks. We know, if we can calculate, that the brightness of this exploded star, it was not very far away, would have been brighter than the full moon and slightly fainter than the current sun. So there should be records everywhere. Now, in the Western tradition, at that time, in the 11th century, nobody wrote that down, because at that time people felt, that was the Dark Ages, people felt that anything like that that happened in the sky was a sign from the devil, and so they didn't write it down. So actually in the Western tradition, there is no mention of the crab explosion. We found many descriptions in the Chinese writings at that time, because as I said, the Chinese wrote everything down. We are looking for, I mean, of course, in India, of course, you saw 2 suns in the sky for 2 weeks. So people would have written down these things. And we are looking everywhere. I have colleagues who think they have found some paintings in Kashmir which might describe such things. But this is just an example. There are wonderful events that have happened in the last 2,000, 3,000, 4,000 years, and there would be proof of observation of these kinds of things in literature, in writings, in sculptures, in art, and in people writing things down. And there needs to be a lot of research that we need to do now. There are some lovely books. What we will do is after this talk is finished, please look at the Facebook page of Vigyan Bharati, and we will put together some more of these questions and their answers. And also what we will do is we will give you a list of books that you can read. I can see a lot of people asking questions here. There's somebody called Venkatraman, there's somebody called Madhav, who have said, are there any books that we can read, we can follow up? And it would be good that, for example, I have with me a wonderful book called The History of Indian Astronomy, which is a book which is a collection of articles from a conference that happened in Pune, organized by my colleagues in ISA Pune and TIFR and Bombay about 2 years ago, which has a lot of lovely articles. But there are some lovely books on the history of astronomy from the Vedic period till now, and I'll put together a list, and you can follow up, and you can get some of them on the web as well. Okay, I think the time is up. Thank you very much for listening. Namaskar and Jai Hind.